Okay, today we're going to work on an example of graphing absolute value equations. And this is going to be right out of the book. It's actually on page 359, and this is example 1 on that page. Example 1 gives us an equation of the absolute value of 2x plus 1 minus 2 equals 5. Now our calculator can't handle an equation like that. Here's the y equals. So it wants y equals something. So all we're going to do is we're going to take this and split it into two equations. And we're going to say y equals the absolute value of 2x plus 1 minus your 2. And then we're going to set another y equal to 5. And all it is the two halves of the equation. So let's call this y1, and we'll call this y2. So to set equation y1, first we have to pull up our absolute value function. And to do that, I go to Math, shift over to Number, and 1. That's going to give me the absolute value, so I'm going to plug in my 2 times x plus 1. Now I'm going to hop out of the absolute value bar, and I'm going to subtract the 2. So there's one equation. For the second equation, it's simply 5. Enter. Now when I go to graph those two equations, the v is obviously my y1, and the straight horizontal line is obviously my y2. My answer to this equation is going to be where the two equations meet, where they intersect, right about there and right about there. In order to find that intersection easily without guessing, because technically I could hit trace and I could go up and down, but sometimes you get into a situation where you don't know if you're right on the intersection, and you can see by my numbers they're all large. So I'm not going to use the trace. So I'm just going to get out of that. I'm instead going to go to Calculate, and right here for number 5, I'm going to find the intersection of this. Now it's going to ask me to put in my two curves, and you can see here they call it curves. Now technically these lines that are in our equation aren't curves, but I think you get the idea. So right here, that's on the V, so I'm going to hit enter. Yes, that's the one I want. And the other one, that's the straight line there, and that is in fact the other curve that I want. Now it's asking me to give it a guess. Where do I think the intersection is near? So I'm going to arrow down to right about there, and all you have to do is get into the ballpark. With this formula that they're using to find this intersection, they're using this first guess to get them started. And then after that, they're going to go through a couple of calculations to hone in or improve that guess to give you your exact answer. So now that I have my guess in, I'm going to hit enter. And there is the intersection. So let's look at this for a second. It's saying my x is 3 and my y is 5. Well, we knew the y was 5 because our whole horizontal line is y equals 5. So the answer we want right here is x equals 3. So I'm going to write that over here. But because all absolute values, or most absolute values, have two answers, we need to come over and do this again. So we're going to go to Calculate. Again, intersection. But this time, I'm going to come all the way down to this side. There's my first curve, if you will. My y equals 5 line, horizontal line, is going to be my second curve. Now my guess, I'm going to get in the ballpark there, make that guess, and there's my intersection. This time it's saying x equals -4. And still y equals 5, which should be expected. So there's my answers to my equation. I'm sure if you go ahead and plug in x equals 3 or x equals -4 to our original equation, you'll find that they work perfectly.